Exponent Laws, and some of you will have seen these in grade 9. Okay, what have we covered so far? Right, so far, right, we talked about rational versus irrational numbers. Right, that should ring a bell to you right now. Rational versus irrational numbers. How do you recognize a number is rational? Can be written as a fraction, decimal, repeats, or stops, right? One of the two. And irrational is just decimal, does not stop. So either one works, right? Like either you remember what an irrational is or you remember what a rational number is. Okay? Let's put some examples in each camp, right? So a rational number, obviously a whole number, right? Whole numbers, whole integers would work. The square root of 4 would work because that actually ends up being a 2, right? The square root of 1 over 9 would work because that ends up being 1/3. So whenever you can actually, whenever you have a perfect square, a perfect cube, if it matches the index, right? If you are able to take it out, that would be considered a rational number, right? And going further to just confirm my case, 1 over 3 is 0.333. It repeats, right? And so it would match that category as well. It can be written as a fraction and a repeat. So it needs to actually fulfill all of them, but you just make sure it fulfills one of them, right? Irrational would be square root of 3. Can't do it, right? Cube root of 5, for example, right? Pi. Anything like that would be considered irrational. Can't take it out of the root, right? Can't do it, so it's technically you're stuck with irrational numbers. Right? So that's the first thing we did. Then we talked about radicals, and I'm just quickly going to do that, right? Entire versus mixed. This is all in detail in the video, okay? So if you have, right, the square root of 10, that would be an entire radical with an index of 2, right? How can that be written as a mixed? Well, you can write it as square root of 2 times 5. That was a bad example, sorry. This is supposed to be at 20 here. Change that to 20. And 20 is the square root of 4 times 5, right? And we know that, right? I'm going to come down here. We can break that up into root of 4 times root of 5. Okay? We can break this down. And that will then, we know that the square root of 4 is just 2, and the square root of 5 cannot be done. So this is a mixed, and this is an entire. So this is possible, right? To go from here to here, and we also we went backwards, right? We were able to go from here to here, and again, if you watch the video, that's 4.3, by the way. This is 4.3, section 4.3 in the text. I walk you through how to go from here to here and how to go from a mixed radical to an entire, okay? So just putting that out there. let's actually talk about the exponent laws now. So I just decided to talk about the review stuff just briefly to kind of remind you, because if you watch this on Monday, Tuesday already, right, like it might be a little bit dated already. So if you have 2 to the power of 3, let's say, okay, this number up here we call the exponent. This number here, like, we call that the base, right? And the entire thing is what we refer to as a power. Okay, so a power is the whole thing. We sometimes say 2 to the power of 3, right? But really what we mean is that the exponent is 3 and that the base is 2. And here are the laws, right? In no particular order, but let's say you have a to the power of m, and you multiply it by a to the power of n. So they have different powers, but the base is the same. Then we can add the exponents up. And I will tell you this, the exponents are going to soon end up being fractions as well. So it doesn't matter what the exponent is, you add it up, provided that the base is exactly the same. Okay? And then next here, if you have a to the power of m like this over a to the power of n, that would actually translate to a to the power, it's always the top one, subtract the bottom. Okay, so that's another rule. And then you have, they have names, but maybe I'll talk about the names later. I feel like if you just know how to work it when you see it. If you have a to the power of m and all of that to the power of n, this is called power of a power, then you multiply them. Then it's a to the m times n. If you had a, b like this in a bracket, and that product is raised to the power of m, you can actually break it down into a to the m times b to the m. That power is applied to both of the terms or the elements in there. And this, by the way, you always have to generalize, go big, right? You could have A, B, C, D. You could have a number of things multiplying. That power would apply to everything that's in it, okay? Everything. So there it is. Then we have this one, which is similar to this. If you have a to the a over b, and that whole thing is raised to the power of n, let's say, then it just means that you can apply, you can get rid of that bracket and apply that power to both whatever is inside, by the way. And I'll give you some examples next to each of these here. Okay, so let's say you have some examples on this side. So for that one, let's say you have 2 to the power of 3 times 2 to the power of 4, let's say, right? Then you would just say, hey, that's 2 to the power of 3 plus 4, and that's 2 to the power of 7, okay? For this rule here, let's say you had 4 to the power of 5 over 4 to the power of 3. like this, that you have the same base, but they have different exponents, of course, right? It doesn't matter what kind of exponents they have, as long as the base is the same, you can say, hey, that's 4 to the 5, subtract the one that's in the bottom. So it's really 4 squared, which we know is 16, right? We can come up with that pretty quickly. Okay. This one here, if you have 5 to the power of 2, right? And you have another exponent out there like that, that would be the equivalent of 5 to the power of 2 times 3, which is 5 to the 6th, which is a big number. We're not going to calculate that. Okay. This one here, I'm going to use variables. So let's say you have 3x, and I'm going to put a squared on this one here. Okay. 3x squared, and let's say that whole thing is raised to the power of 3. So you have two different things, and you could have more, but you have that bracket, so that means that that power is affecting everything inside. Okay, so that means that we have 3 to the power of 3, right, times x to the power of 2 times 3. And you're saying, Mr. Erickson, why did you go 3 to the 3 right away? What's the power of something that, if it's not there, what is the power? It's 1, right? So 3 times 1 is just 3, right? So you can automatically just plug that in. But if that term has its own little power inside, you multiply these two. Okay? So that would be actually, we know what 3 to the 3 is, right? That's 27. And this is x to the 6. If you have 2/3, let's say, and you raise this whole thing to the power of 3, you could actually say, hey, that's 2 to the 3 over 3 to the 3. Right? It applies to both of them, and we can actually go further. 2 to the power of 3 is 8, and 3 to the power of 3 is 27. Okay? So we have a couple more here. I usually talk about them later, but a to the power of 0, anything to the power of 0 is just 1. Anything you can possibly think of, if it has a power of an exponent of 0, it's always going to be equal to 1. And here's another example. 1 to the power of anything is just going to end up being 1, right? So it's like all these laws, right? But you'll get used to them in a bit. And then this is the last one, I promise. I will talk about this more specifically later on, but I will already introduce this. If you have a to a negative power, negative powers, yeah, you'll see how that goes. That is equal to, you can bring this down into the denominator like that, and then the power changes sign. Right? The same goes like this. If you had 1 over a to the negative m like this, if the negative exponent is in the denominator, you can bring it up, and the exponent turns positive. And the 1 is just there to hold the place, right? So you bring that up to the numerator, and then it changes the sign of that. So this is more later on this. This is called the negative exponent law. Somebody joined. Is that Dale or someone? Is it Dale? Okay. You're here? Okay. There was somebody else yet. I don't know if you joined later. But Danielle, okay. And Dale. Okay. All right, let's keep going back here. I will just make a note. A negative number with an even exponent will turn positive. Right? A negative number with an odd exponent will end up being negative. Okay, that's something that students miss quite often. So example, right, if you have a negative 2 to the power of 2, that is actually saying negative 2 times negative 2, right? Which negative and negative will turn out to be a positive 4. And so if you had negative 2 to the power of 4, which is also even, that would be negative 2 times negative 2 times negative 2 times negative 2, right? And if you think about it, these two here will turn into a positive, and these two here will also turn positive. So now your whole, right, the whole thing ends up being positive, right, because of that. So we know that this is 16 positive, right? However, if you have negative 2 to the power of 3 or negative 2 to the power of 5, right, this will be negative 2 times negative 2 times negative 2, right? This turns into a positive, but then you multiply that answer by negative, it'll be negative 8. And here you have negative 2, negative 2, negative 2, negative 2, and another negative 2. You have 5 negative 2's multiplying each other. You get a positive out of these, you get a positive out of these, but then you get a negative here. Right, so positive times positive, like the answer of these two will be positive still, but then eventually you end up with that one left over. You'll always have one left if it's an odd power, so that ends up being negative 32. Okay, so don't forget the negative. I think this is the one that students miss the most. Like if you have negative 1 to the 5, without writing it all out, what will it be? It's odd, so it just be negative 1, right? If it's negative 1 to the power of 8, even, right? So that'll be a positive 1, even exponent. This is an odd exponent, right? It's huge. You might think, yeah, I got it. Yeah, I got it. But later on, this is just going to be in there with a bunch of other stuff. And if you miss that point, it's going to frustrate you quite a bit. Okay, simplify the following. So we're going to start with what I call one-liners, and then we're going to start having numerator, denominator. Okay, so the one-liners is just one line, and then you're going to have more added to the mix. So 3y squared, and it's still is very heavily based on, right, your knowledge of the previous unit still, except for we don't really do polynomials here. It's just expression times another expression, right? That's a lot of that is happening here. Okay? When you have something like this, it's just like before. You multiply your numbers, right? That's just a straightforward 12, right? I will go with x first, right? There is no x here, there's just that x there, so this your final answer will have x. Then there's y squared times y squared. That is technically y to the 2 plus 2. Remember, if you multiply two things with the same base, you're basically adding the exponent. So I'm applying that property here. So that ends up being 12x y to the 4. If you put y to the 4 and then x, I'm not going to take any marks off, okay? As long as the exponents are right. B, let's go 3n times 2m squared n times 5n squared. How's that? Okay. So again, multiply your numbers. Okay. Maybe I'll put on the side here numbers first, right? Add exponents of like bases. Numbers first, then add exponent of like bases. So you can actually go like this, okay? These are just expressions multiplying. There's no adding or subtracting here. So you can go 3 times 2, which is 6, times 5 is 30. Okay? And then you can choose. I'm going to go with the m maybe first. There's no m there. There's no m here. So it's just m squared. And then I look n, right? N times n times n squared. So they're all the same base, right? So that is really saying n to the 1, right? This one here, plus 1, that exponent that was here, plus 2, right? So you basically are combining all of these into just one base with the appropriate exponent. And that'll be 30m squared n to the 4. Some of you, like, you will do this later on just like that. You don't have to show me this, but I'm just showing you that I'm applying those properties. 3x to the, I'm going to put this 2 here. 3x squared to the power of 4. This 4 applies to everything in there. So it's 3 to the power of 4, and it's x. This is different, right? This is a power of a power, so it's like 2 times 4. Not adding, this is power of a power, you multiply them. And 3 to the 4 is really, right, 3 squared times 3 squared would be 9 times 9. We know that that's 81. And this is x to the 8. So whenever there's a number with a power, make sure you work it out, okay? Number with power with exponent, right? If that's right, work it out. Actually calculate what it is. Don't just leave it 3 to the 4, but obviously variables, we leave them as is. D, if you ever have something like this, I want you to note that there are no brackets. Okay, so really this is the same thing as -1, that's that one, times 2 times 2. Because this exponent is only affecting the 2, not including the negative. So the negative, you got to give it a placeholder, which we do -1, and then we multiply 2 times 2. So if this had been in brackets, the whole thing, yes, it would have been a positive answer, but in this case, it's -4. I'll just make a note. Negative is not inside a bracket. Just in case you're not wondering what happened there, right? E 4 x squared y cubed z, like that, all of that raised to the power of 3. Again, every single item is affected by that. So we have 4, right? 4 to the power of 3, because it's really, it has an exponent of 1. So it's 1 times 3 is 3. And then times, I will get rid of the times later, right? X is 2 times 3 times y, 3 times 3 times z, 1 times 3, which is just 3. And that ends up being 4 to the 3, right? 4 times 4 is 16, times 4 is 64. 64, x to the 6, y to the 9, z to the 3. That would be your final simplified way of expressing that. So you could have a mumble jumble in here. You could have the craziest expression. As soon as it's to the power of 0, that whole thing turns into 1. Okay. So that was just to remind you of that. G. We have 4. This is now turning into a 2-liner, right? Numerator, denominator. So here you have to pay close attention. You always, when possible, when it's a fraction, you try to simplify your numbers. Okay, guys? You try to simplify the numbers, like simplify that fraction. And this is how I do it. I see that both of them are even, right? I can clearly tell that 2 goes into both of them. And by the way, it will be pretty obvious. Most of these expressions are not going to have huge numbers, okay? So you'll be able to tell, yeah, 3 goes into both of them, 5 goes into both of them, and so forth. So this is how I show it on my work. 2 goes in here twice. So you cancel it out and you put the replacement of it, and you say 2 goes into 2 once. So now it's 2 over 1 really that you have there. So I will put on the side, simplify numbers first, right? when it's a fraction like this. And later on, I'll give you a bit of a step-by-step, just like I did with factoring. But right now, you're a little bit too new to this, so I don't want to bombard you with more steps. So that means that, okay, I'm going to turn this into a one-liner. So I have the 2 here, right? That's still there. And I notice that I have 2 x's here. So that means that it's x to the 4 minus whatever's in the denominator, 2. Sorry, my paper is, I have to get better paper. This is the lightweight, right? So x to the 4 minus whatever is down here, guaranteed. And then you're going to continue y. There's a y here and a y there. It's going to be 5 minus y power of 4, right? Exponent of 4, like that. Because you have like terms here, like bases, right? And I hope this isn't going to make it worse here. I hope it doesn't. Oh man, almost. Maybe don't do that. Didn't work out very well. But the like basis, you always go top minus bottom, okay? Some students mix it up. They go 2 minus 4. That's totally different, okay? It's top minus bottom. Subtract exponents of like bases. Top minus bottom. Okay, so I've turned this into a one-liner, right? It started off as a fraction, but I've done that. And this 2 turned into a 1 because I simplified it, so you don't have to worry about putting a 1 here, right? Normally you would go over 1 because it's still there, but we don't worry about it. So now let's write the simplified form of it. We have 2x squared y, right? That's it. Y to the 1, right? Which is just y. Is your head spinning already? All right. Hope not. So let's do a couple more like that. And there are more ways of showing this. Perhaps I will do it on the next page so you see why this would be true. I will show you on different examples. I don't have room here for that. If you're at home, go ahead and copy this. Okay. Where were we at? G. Okay, H. 3m to the 6 n to the 3 over 6 m to the 4 n. And I will make a variation of this in a bit. I'm not going to change it a whole lot, but just so you see how it will be different if that were the case. So again, don't forget the equal sign, okay? Even if you're factoring, like if you have a trinomial here and you're doing the work underneath, put equals and then, right? Like if you have your 2x squared plus 4x, right, minus 3 or something like that, like make sure you have the equal sign. So you're saying that this is equal to that, right? That's really what you're saying. Numbers first. 3 goes into both of them. So 3 goes in here once. 3 goes in here twice. So you've simplified that fraction like that, and that's how you show your work. That's the first thing you want to do. And then you bring this over. Technically the 1 is here. I'm not going to put that down. But the 2 is in the denominator. You can't just leave it, so you got to bring it with you. Right? The 2 goes with you in the denominator. In this case, if it's not 1, if this isn't 1 down here, you need to bring it with you, okay? And now we're going to go m and m, right? They have m and m. I'm already craving that, right? 6 minus 4, right? Same base, I can subtract. And then I have n, 3 minus 1, like that. So I'm bringing everything together, okay? That's part of simplifying. And that will be, at the top, I have m squared, n squared as well, over 2. So I know it looked kind of odd here. I put the 2 up front and then nothing here. But sometimes you'll have something here. That's why for now I just put it up front, and then I end up cleaning it all up, right? So I don't need to have anything there. So this is the simplified version of that. All right. I'm gonna use the top here to guide me, okay? I'm gonna use the top almost the same, but I'm gonna change something to it. Watch this. This is where the change happens. N to the 5. That's where it's, and the 9, of course, right? And one more thing, because we don't like negatives, okay? So I'll make this negative so you get used to it. You're gonna have to face your biggest fear. You know what I mean? You're scared of spiders. They put you in a room with spiders, right? No, don't do that. But I'm just saying. So we have this scenario here. This is a pretty clean case, by the way. Like there's no big brackets, you know, with another exponent up top. So right now this is pretty clean. Okay. So we know 3 goes into both of them. This is negative though, okay? So just leave it there for now. 3 goes in there 1 time. 3 goes in here 3 times. Okay, so it's 1 over 3. Does that make sense when I'm doing that? I hope so. And then you're going to go over here and say, okay, equals that negative. I'm not going to forget. Remember, I promise not to forget the negative, right? So that goes with you. The 3, you were not able to completely cancel that out into a 1. So you know you're going to have a denominator. So you're going to put that 3 there. Okay, and you brought the negative with you. I always float it to the top. My negative always floats up. Some problems will have it in the denominator. Just bring it up. It still makes the fraction negative. Okay, so it's m to the 6 minus 4. And then it's, watch this. This is where it gets tricky. N to the 3, it's always top minus the 1 on the bottom. And you're like, wait a minute, that's going to give me a negative. Absolutely, you are right. So let's come over here and clean it up. I would always suggest you actually show this work, because down the road you're gonna forget something if you don't. N to the negative 2, watch that. I'm gonna highlight that. Over 3. I'll make a note here. You should not have negative exponents, right? And your final answer, that is. You should not have negative exponents in your final answer. this is where I'm gonna show you that law that I gave you today. Just 1 second. Remember that one? If you have a base with a negative exponent, you can just bring into the denominator, right? It also goes vice versa. If you have one in the denominator, you can bring it up to the numerator. But most of the time, you're going to use that first one. The way I'm teaching, at least, that's how you're going to do it. So that means that the negative m squared stays in the numerator, but this guy is going to come down like this. This is the correct final answer. No negative exponents. If you do have any, just bring them down. Okay? And that's it. So we did not forget about our negative. We brought it with us every time. Okay? Let's do some more here. Let's use different letters. And if you, I don't know if you ever look for on YouTube for like a better explanation, they may not do it the exact same way I do it. But what I found is if I stick to this method, there are fewer mistakes. Okay. So that's all I'm going to say to that. You just got to watch out for that. Okay. So they may look easy at first, but then you'll run into troubles later. Okay. Let's simplify this thing. Okay. Fraction, it's not a one-liner. Okay. So we need to clean this up. The negative, I'm going to bring it with me here. It floats up. Right. And then I look at the numbers, and I know that 9 goes into this 3 times, and 9 goes into this 1 time. Perfect. Cleaned up business there. So I can go 3 here, and I look. There's a in both numerator denominator, so I can actually do a to the 3 minus 1, because remember, if a is just that like that, it has an exponent of 1. Then I have b upstairs and downstairs. That's 4 minus 5. I have no c, right? What's up with that? Just leave it then. Don't do anything with it. So we go to the denominator, and what are we left? We took care of a, right? We took care of b's. This c just stays there, because there's no like term upstairs, right? So just leave it like that. If you bring it up, then you're gonna have a negative, so you don't want that. So negative 3 a squared b to the negative 1. You do have to make sure you put that negative 1, right? And then c squared. I don't want negative, so I'm going to bring it downstairs. So remember, these are all multiplying each other. And if you bring it down, it's going to multiply down here as well. So we go negative 3a squared over, and it's up to you how you want to do it, b c squared or c squared b, but you brought this one down with a positive 1, right? If you want to write it down for yourself, you can do that. But technically, conventionally, we don't do that. We don't go plus 1, but it's not wrong. to do so. Okay. Is he going to go through the whole alphabet? Maybe. No, I won't have time. Let's now go one step further, okay? The reality is it's like an onion, right? Like it can make more layers and add more layers of difficulty, but if you're consistent, you won't have to worry about it. You will just have to take your time and show your work step by step. The biggest mistake is wanting to jump the gun to the end, right? I can do this in my head, right? I wouldn't recommend that. I would strongly advise against that because you're gonna run into trouble, okay? Especially you'll see later on, it'll take you multiple steps to get there. How is this harder, Mr. Dirksen? Well, remember we did one-liners, right? We just did one-liners, and then we did something like this where you just had one expression, another expression. Now you have things happening in the numerator, and it could also be happening in the denominator where things are multiplying, right? Bracket, bracket. So you need to do that first, okay? You can't cancel out the 4 with the 14 or the 7 with the 14. Don't do that just yet. Just trust me on that. So we will do the numerator first, right? Do numerator first, okay? And I'll give you steps later on. So 4 times 7 is 28. X squared times x to the 3, that is x to the 5. That you can do just like that. We're adding exponents technically, right? Y to the 4 times y is just y to the 5 over 14x y to the 5, like that. And now you've basically turned this into what we were doing before. It's just expression, expression. Everything is multiplying in the denominator. So you basically cleaned up. If there had been two brackets down here, you would also want to multiply them first and then just come up with one expression here. I can see that 14 goes into here once. Oh, sorry. Goes in there twice. 14 goes in here one time. So now you've reduced that to 2 over 1. And so you have the 2 in the no negative. I'm checking. Yeah, we're good. And then x to the 5 minus 1, right? Because these are equal bases. What about this? I'll just do that, but I will later on just tell you to cancel them out. And what about is there anything left in the denominator? There's a 1 there, which I don't need to worry about, okay? That ends up being 2x to the 4. And what does this turn out to be? 5 minus 5 is 0, right? Anything to the power of 0 is 1, right? All right, that's what I play with my boys all the time. They're sick and tired of it already. They want to go outside and play. But anyways, 5 minus 5 is 0, so that's just 1. Don't put this down. That's just what it is, okay? 2x to the 4, you're done. Maybe I'll do this because some of you might wonder, what happened? It's just 1, right? So that's just a side note there. Okay, here. Now, 6x to the 5, y to the 3 over 8y to the 4, all of that raised to the power of 2. yeah, I'm gonna do, yeah. I'm looking at your homework a little bit. Some weird notation there. Okay, are you having fun yet? Okay, when you have, I'm looking first, okay, I'm tell you where we're going. I'm looking at the numerator. Are there brackets that I need to multiply out? No. I'm going to look to the denominator. Are there brackets that I need to multiply out? No. Now I'm going to try to simplify this first, just like we have been doing. And my last step, the very last step, I'm going to apply that outside exponent to this whole thing. That's the last thing I'm going to do. So you kind of go from the inside out, all right? So I'll make a note here, move from inside out, okay? And so basically this is what you could be having here. Almost looks like some kind of emoji, right? So you take care of these, you take care of these, then you take care of up and down what you're left with, then you take care of what's outside. Okay, and I'll give you these steps. I'll write them down for you down the road because it's gonna get crazier. Okay, but I'm gonna guide you one step at a time, so don't panic, just practice. Okay, I don't need to worry about brackets, so I'm gonna worry about simplifying. So I see that 2 goes in here 3 times, 2 goes in here 4 times. So I'm already simplified my numbers. I can do that. Then I have to take care of the like basis. So watch how my work is going to do. I'm actually going to do this underneath it. I'm going to go 3, like 3, this one, 3 comes with me, and the 4 will be with me down here, right? So I follow that with me. X to the 5 is there, and then you have, there's no other x down here, so it's just x to the 5, and then you go y to the 3 minus 4 squared. So I simplify my numbers, I combine like bases. In this case, the only thing downstairs is the 4. Then I will do my next step here where I go 3x5 y to the negative 1 over 4 squared. And you can move sideways sometimes if you run out of room, okay, that's fine. I'm not picky with that. So then my next step is I don't want negative, so I'm going to go 3x to the 5 over, the 4 is already there, the y will be coming downstairs with a positive 1. All that still squared. And now that you've completely cleaned everything up inside, you apply that outside exponent. So it's 3 squared, x to the 5, it's 5 times 2, right? It's x to the 10 over 4 squared y squared. So the 2 has been applied everywhere. And then one last step is 3 squared is 9 x to the 10, 4 squared is 16 y squared. Yeah, now you're done. One thing I want to mention here, okay, pay very close attention. I would like to rewrite this whole thing with a negative inside. So imagine you had a negative like either here or here, but the whole thing is negative. So that negative would follow you. And it's at the end here. Remember when you have a negative with an even power, you would end up with a positive final answer, correct? So you got to be aware of that. If this had been a negative with a cube or 5 or something like that, your final answer somewhere would have to have a negative. But I don't want you to rewrite the whole thing. But what if the question looked like this? Maybe that's what I will do. Had a negative inside, right? So we would do a bunch of work, and then we would end up with negative 3x to the 5 over 4y, right? That would end up with a negative 3 squared x to the 10 over 4 squared y squared. This negative is not affected, right? It is affected, sorry. It is affected, so what I will do is this. That negative has been affected. It's really a negative 1. It is affected by the power of 2, which will turn it into a positive. Sorry, 9. Positive 9x squared over 16y squared. Okay? So I just want you to be mindful of that negative turns into a positive because you're squaring it, right? Because technically that 2 applies to everything inside. So that's how you need to be careful, very careful with that. If this had been a 3, then it would have been a negative 1 to the power of 3, which turns into a negative. Okay? All right. I'm going to start talking about homework here. There is a page 221 that reviews, right? Review 4.1 to 4.3. So if you're like, okay, I kind of get it, but I need to get another go at it, strongly recommend. But because you'd be amazed how many marks you lose on a test with the stuff that is somewhat easy, right? When I was marking, there were a lot of mistakes made right at the beginning. And so this reviews that. Plus, and this is the most important one, right? Exponent Laws Worksheet. This is the most important one. So I would say do this first and then do this second to review those first 3 lessons I taught on the video, okay? And you're like, what's that exponent law worksheet? I will show you what it looks like. If you came through here, you should have it. I will cover it up for one moment here. This is the one, okay? Do it on loose leaf, don't do it on here. I will show you some pretty interesting expressions that I don't really like, but I don't have the Word document of this. You see this divided by that, you see that? Just write it as a fraction, okay? Just write this out and then it's over this. And then you don't really need brackets around it once you have rewritten it like this. So you don't need it like that, just it's basically a fraction, right? Same here. When you see a division, write it as a fraction. This over that, okay? Like this is really what I wanted it to look like, but sometimes Word equation maker doesn't cooperate. But I think it's also important for you to be comfortable with that. So we start with one-liners, right? And then it goes to two-liners like fractions. This is still all fractions, right? And then towards the end here, you get the harder ones, right? And this is another one that I don't like, 34. Students think that is an x, but it's actually this times that, okay? There should just rewrite it without that x. It's just this times that in brackets over that. So 34, change that. If there's anything that I missed, just use common sense and that it should work out for you. And the answers are also at the bottom there, so you can check right away. So I need you to understand this. There is no section in the textbook that addresses exponent laws. They just like jump right in there. So this is just me stopping, introducing this, reminding you how this works, and then we'll continue afterwards, okay? Other than that, I think